Hey, good morning, guys. I'm Mr. Callan here with your digital lesson for Tuesday. We're doing lesson 3.10, part B. So we're continuing our idea of working with these circles where we're not specifically asked to find radius, diameter, circumference, or area, but they ask it in a way that describes it with other words. So we're looking at this spinner here that you would find in like many games or probability games that you might play or spinning game. And we're going to answer some questions about it. And we already know that the length of the arrow spinner is 8 inches. So we know that from this distance all the way across it, it has essentially a diameter of 8 that's given to us here. And then we have to answer these questions. Now, some of these questions are a little tough, so let's look at them. Actually, I tell you what, before we do that, I'm going to go ahead and set up my circle chart here that has all the parts that I might need to find listed out here to the side. All right. And since we already know the diameter is 8, boom. And if we want to go ahead and do that as well, just to kind of get it started. We know the radius is half, and we know the radius squared is times itself. So we've already got a lot of the circle figured out, but let's answer these tougher questions about it. How long is the curved line for the blue section? Okay, so the blue section is located, let me get a little bit thicker line for this, is right here. And the curved line for that would be what I'm highlighting here in red. So they want us to find how long that this is right here. Okay, so that's definitely not an area thing. That's a circumference thing. And to get to circumference, we got to multiply by pi when we know the diameter. Now, I've already done that, and it comes out really close to 25. It's like 25.12. We're going to round this. This is approximately 25 inches long whenever you multiply it out. So we know that the full curve is 25, but we only want a fraction of that curve. Now, what fraction does it want? Well, count how many colors there are. 1, 2, 3, 4, 5. There's 5 colors around it. So we really just want, for part A, and I'll work it out down here, part A is really just 1/5 of the circumference. And so to do that, we just take the circumference, which we know in this case is 25, and we divide it by how many equal sections there are. And so that means we would guess each of those curves is about 5 inches in length. So that wasn't too bad. We had to think about it, though. It's not just obviously given to us. Let's look at part B. So part B says, how much area is in the green and orange section combined? So they want green and orange together. So we need area to get there. So we got to multiply this squared radius by pi to get there. So when you multiply 16 times 3.14, okay, 16 times 3.14, that gives us 50.24. Now, not 25, 24. We're going to go ahead and approximate that as about 50 inches squared. Okay, about 50 inches squared. Now, that's a nice number for us because this circle has been split up into 5 parts. And technically, the green and the orange would not be 1/5 of the area. It would be 1/2 out of the 5. So this would be the same as 2/5 of the area. And we know that the area is 50, so all we have to do to get this answer is multiply 2/5 times 50. And after a little bit of, fraction work here, 5 goes into itself once and into that 10 times. We can guess that about 2 times 10, or 20 over 1, or about 20 square inches would be our answer for part B. If the whole thing is 50, then 2 out of the 5 is 20 square inches. That makes perfectly good sense. And then lastly, part C. Ben flicks the spinner. He's spinning it, and it does 6 complete rotations in 2.5 seconds. What is the average speed of the tip of the arrow? Okay, so To find speed, all right, speed is simply equivalent to average speed is your distance divided by the amount of time that it takes to get there. That's the ratio. So we have a ratio here, and the speed is essentially the constant of proportionality, distance divided by time. You could also think of it as like a time to distance table, and you're going to compare that relationship. All right. So for us, we know the time is 2.5 seconds. There's my daughter with a mask that doesn't fit. She just got done riding the slide. She's enjoying that. So 2.5 is our amount of time, but we need to find out how far the tip of that arrow traveled during 6 rotations. So 6 rotations means that that would be going around this spinner. Imagine if it started right here, and 1 rotation would be 1 circumference, 2 circumference, 3 circumference, 4, 5, 6, right? 6 times around. And we know that 25 is the circumference. So if we multiply 25 times 6, which is 150, we've got how far it would travel in that 2.5 seconds. So we got the distance. It's 150. So our job really here is just to find out what the constant of proportionality is. What could I multiply by this to get there? Divide the distance by the time, right? 150 divided by 2.5. Now I've got that in my calculator right here, and I divide it by 2.5, and that gives me 60. So that little arrow was traveling 60 inches every second as an average speed. He flicked that thing pretty hard, and it was moving quick. And that makes sense. When you spin that spinner, it goes pretty fast. It slows down at the end, but the average speed was 60 inches per second. And that's our answer for part C, and that's our video for today. Have a good one.